So the second algorithm for page replacement is the optimal algorithm. Okay, so the discovery of Belades anomaly led to the search for an optimal page replacement algorithm. So which is simply that which yields with the lowest of all possible page faults and which does not suffer from Belades anomaly. Okay, so such an algorithm does not exist and is called OPT, right, or mean. What we call it optimal. Okay, so the algorithm is simply replace the page that will not be used for the longest time in the future. Okay, so I'll repeat. This algorithm follows replace the page that will not be used for the longest period of time. Right? So with this one, we have to consider, or we are considering actually the future. Okay? So for example, figure shows that by applying OPT on the same reference string used in the for example previous on the previous slide, okay, so we will come up with 9. Okay, so let's see that. So given this 20 reference string, okay, so 20 pages, and using the same number of frames, so 3 frames. So let's see. So initially all frames are free, so allocating 7, 70, and 701. So after allocating 1, we need to choose or select the victim. So the victim would be the frame that we need to replace. And according to optimal, we need to replace the page that will not be used for the longest period of time. So that means we should be looking for the future. All right. So how do you know this? So can you read the future? So this one you have to refer to the future page that will come. Okay. So in that sense, so after plotting 1, you've got 701 here. So we need to choose the victim to plot 2. And in that case, the victim is 7. So why 7? Take note that when you say optimal, you have to refer to the future. 7 will be used on this position. Alright? So whereas 0 will be used next and 1 will be used before 7. So therefore, the page that will not be used for the longest time period here is 7. So that would be our victim, replacing 7 with 2. You've got 201 here. Alright? So next is to plot 0. 0 is already allocated. Next is to plot 3. Now, who's the victim here? Okay, so that we can accommodate or plot 3. Okay? So 0 should not be replaced because that's next. Alright? 2 should not be replaced also because after 0 it's 2. Alright? So and therefore the page or the victim would be okay would be 1. Okay, so 1 will be seen far or in the future. Okay, far from 0 and 3. Alright? So next, let's try to allocate 0 here. 0 is already allocated. We got 4. Allocate 4. Okay, so it's our victim here. 2 is next. So that should not be replaced. Alright? So 3 is next. So 2, 3. Okay, so the longest period would be 0. So replace 0 with 4. Alright? So plot 2, 2 is already plotted, 3 is already plotted, plot 0. Alright. So 3 is next, so do not replace that. 2 is next, right? So 4 will no longer be used here, so we replace it with 0. Okay? 3 is plotted, 2 is plotted, plot 1. 2 is next, so do not replace 2. 0 is next, do not replace 0. So replace 3 with 1. Alright? So 201, these are all plotted. We need to plot 7. 0 and 1 is next. So do not replace 0 and 1. So replace 2 with 7 here. Alright? So with that process, so we have 9 page faults. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 page faults. Alright? So Since 6 of the page faults are unavoidable, so that would be the first reference to each new page, PFO can be shown, okay, so to require 3 times as many extra page fault as the optimal algorithm. Okay, so unfortunately, OPT cannot be implemented in practice. Why? Because it requires foretelling the future, that's what I'm saying, right? So, but it makes a nice benchmark for the comparison and evaluation of a real proposed new algorithm. Okay, because OPT or the optimal tries to evaluate the forthcoming pages. Okay, and you cannot read the future. All right, so we call it foretelling the future. Okay, so in practice, most page replacement algorithms try to approximate OPT by predicting or estimating in one fashion or another what page will not be used for the longest period of time. Okay, so the basis of PFO is the prediction that the page was not brought in the longest time ago is the one that will not be needed again for the longest future time. Okay, so but as we shall see, there are many other prediction methods, all striving to match the performance of optimal. But in here, since we cannot foretell or we cannot foresee the future, then if we have that condition or if we are in that situation, we will be using first in first out as our prediction method. All right?